All right, folks, so just a very quick review of how our angles that are given on a Cartesian plane like so, how our angles are related to how our x, y coordinates and radius are related to our adjacent, opposite, and hypotenuse sides. So let's say we have a terminal arm like this here in quadrant 1, and then my principal angle would be right here. We'll call it theta 1. If this is what I'm working with, then this theta, this terminal arm, my x-axis right here, and really my y-coordinate will create a triangle like so. Now, my coordinate right here would be xy. My point is at xy, where my x-coordinate is right here, and my y-coordinate is right there. Now, if I am exploring this a little bit further, then my theta 1 right here, always my theta 1 will be there. If I'm in quadrant 1, theta 1 will be shown like this. Well, theta 1, the adjacent side to theta 1 will always be down here. It will always be across like this. This is the length of my adjacent side. And really, you might notice that length is given by my x value. So here we can observe, if we we'll do it in orange, we can observe that our x value is equal to our adjacent side. All right, we'll hold on to that for now. Now let's take a look at our y value. Well, our y value is given by this length right here. Well, this length is the same as this length right here. If y is the coordinate of a point on this terminal arm. So our y coordinate here is always going to be opposite to our angle, and that is our y coordinate is equal to our opposite side. All right, well, that's all well and good. The last thing we'll observe right here is our radius, which goes from the center of, from the origin of our Cartesian plane all the way out to this point. Our radius is given as, and really this is x squared plus y squared. That's our radius. Okay, so we can take that a little bit further, and and that is also, that's our hypotenuse. Good. So let's say, for example, we happen to be working with a circle. And I am, I meant to be timing this, but I'm not. I want to make sure I'm keeping it less than 5 minutes. But let's say we're working with a circle with radius 1. All right, so let's see here. There's a circle. We'll center it a little bit better for us with radius 1. If it's a circle of radius 1, then this is 1 unit away. This is 1. This is -1. And down here as well, -1. If that's the case, then any point on this circle we can create, and this time I'll work in quadrant 2, I can create a triangle just like the one I created before. Now this time, so my terminal arm is right here. This time, my x value down here, my x value, my y value is up here. Then where I'm working with, still, we will notice my angle theta is here. Well, that's great. What I'm working with under here, that's my related acute angle. We would call that alpha. Well, with the related acute angle this time, I have my opposite side as my y coordinate. And really, I didn't show that very well, but it's this height. That's my y coordinate, right? So my opposite side still equals y. My adjacent side down here equals x. And we can work into, and because our radius equals 1, then we can work into our sine, cosine, and tangent ratios. Well, our sine ratio, sine of theta, our sine of theta ratio is always going to be our opposite over hypotenuse, right? Our cosine is adjacent over hypotenuse. Our tangent is opposite over adjacent. Well, our sine ratio, if we're working with the opposite over hypotenuse, remember, whether we're working in quadrant 2, like this second sketch, or in quadrant 1, like the first sketch, x is equal to my adjacent side. X is equal to my adjacent side. Y is equal to my opposite side. So if the sine of theta equals opposite over hypotenuse, that, and I'll give myself a tiny bit more space here, if the sine of theta equals the opposite over the hypotenuse, that equals the opposite, which is y, over the hypotenuse, which is my radius. Well, the radius in this case equals 1, so that's like y over 1, and that's like y. So this relationship, this is the key, is that sine of theta equals y. My cosine is adjacent over a hypotenuse, that is x over r, and that is really x over 1, which equals x. So my cosine equals x, and my tangent opposite over adjacent, here I'm working with y over x. Okay, so these relationships, when we are working with the unit circle, the sine of theta equals my y coordinate. The cosine of theta equals my x coordinate. The tangent of theta, oops, and I forgot my thetas over here. My tangent of theta equals x, y over x. All right, we'll be using these ideas as we go through the next lesson. I just wanted I wanted you to ready yourself with them so that we can jump right in.